Welcome and thank you for joining us for our third episode in our Top Trends in Energy video series. My name is Chris Arend, Business Applications Sales Executive for Energy Accounts at Microsoft. In previous energy industry trends video series, we focused more on the supply side of conversations of the utility industry. Today's session shifts our discussion focus on the demand and consumption side of this important conversation. We're excited to speak with Bill Kent, Executive Director of AEE, the Association of Energy Engineers. The nonprofit association is dedicated to serving its members and other industry professionals in improving energy efficiency, reducing greenhouse gases, making buildings perform better, and helping to reach global net zero goals. Bill's experience in the energy management industry covers 30 years, and he brings expertise in energy efficiency, automation, building systems, and executive leadership. His current focus is on promoting the vision and mission of AEE to both developed and developing countries around the world, and improving people's quality of life and economic advancement through clean energy solutions. Bill's also a certified energy manager and serves on numerous boards and advisory groups.
Thank you, Chris, and certainly a pleasure and an honor to be here today.
So one of my first questions for you, Bill, is as we're trying to control our carbon footprint, knowing that's our focal point for getting to net zero, with 51 gigatons of CO2 equivalent emissions generated globally per year, we need at least 5 gigatons of annual carbon avoidance or removal by 2050. We know that breakthroughs are happening faster than ever. What are the kinds of breakthroughs making the biggest impact on reducing these greenhouse gases that you're seeing in your field of work?
Wow, Chris, putting it in that perspective, it's certainly a challenge and an opportunity for all of our engineers, and they do love challenges. I think, as you mentioned, the very first and the thing that's having the most impact is renewables. Solar and wind are now the lowest cost of energy on a utility scale basis, which is fantastic. So now we have this great renewable resource. In addition, there's lots of other technologies, looking at green hydrogen and getting that to scale and proven. Also advances in storage. Those are having are going to have massive impact on reducing our greenhouse gases. We also move to electrification and decarbonization, getting rid of or getting away from, fossil-based, carbon-based fuels and energy supply, whether it be coal, natural gas. So one of the challenges that we're seeing is how do we do the integration with these intermittent resources in order to reduce our carbon footprint and our greenhouse gases, and at the same time have a good transition with reliable and resilient energy.
Well, clearly this transition to clean is multifaceted and there's a lot to it. Lots of what you talked about was different types. But with things that we do know related to the power and utility companies globally is they're faced with significant operational challenges due to climate change, the rapid growth of renewable energy, as you were referring to. As a result of all of these, utilities increasingly looking for digital solutions to help them match electricity supply and demand. Could you comment a little bit, and how do you see the impact on consumption from the traditional consumers of power?
Sure, great point, Chris. So I think the first thing is that, it's certainly changing. We've probably seen more change in the past 10 years than we've seen in the past 100, and we'll continue that going forward. I think the first thing is the traditional utility model is going to have to remain there. Large power plants and the distribution, that's got to be part of it. But I think the big change is that the utilities and the consumers are now going to be both part of an integrated solution, okay? I'm going to say it many times, is that energy efficiency is the first key. Certainly, if we're looking at, if we can reduce our demand 20, 30, or 40%, that's going to be less, load and demand we have to integrate across a smart grid. Certainly, automated building systems, smart and energy efficient appliances are key. We're going to be seeing the massive integration of smart grids, distributed and decentralized power generation, and distributed energy resources, whether that's solar and wind, whether that's your car, whether that's battery storage. Certainly a flexible demand and a flexible grid. we're really going to be looking, I think, at almost a virtual power plant, so that whether you're producing or consuming, that there's going to be this massive amount of integration, and data is certainly a huge and critical part of that. So as we integrate renewable storage into a smart grid, we're going to need more and more data from devices, from buildings, and I think we're going to see a massive integration of AI.
Well, we know change is not easy, right? We know that it takes time. And so I love the fact that, we're naming lots of solutions. It's not one thing, it's many things. So kind of to that end, what we do know is that the grid is evolving, right? The electric grid, the distribution network, it's now to include consumers and these commercial buildings. What can buildings do to help utilities with demand forecasting and optimization so they can provide reliable distribution to us and reduce the cost to provide energy?
Sure. So buildings, I think the first thing is that we have to change our whole process of how we think about buildings. Instead of just, they're a passive user on the grid, a demand and a load, is they've got to be an active participant in the supply and the demand. So we have to change the mindset and realize they're a part of these distributed energy resources. And so the building, they're got to be intelligent. They're going to have to share this data also with utilities. But buildings are not only going to be able to consume data, they're also going to be able to produce data. Okay, and so consume it and produce it, whether it's be through renewables, whether it's be storage they've implemented, and also have the flexibility when we connect and have this smart grid to shift the load, right? Shift the load, shift the demand based on the load curves. I think about electric vehicles, and we're going to have more and more electric vehicles, as a part of our system. And, an EV is essentially some batteries on wheels, right? So whether you charge it during the day, whether you charge it at night, the EV can be a source of both energy storage and energy supply. And if you have all your occupants of your building with EVs, that can be, certainly a very intelligent part of a flexible grid where they could store, they could also supply. So I think that this demand flexibility is going to be really critical. And I think having intelligent buildings that are producing and that are actively engaged in the grid, as really a distributed resource is really going to be the answer, as we have. And once again, we're going to need AI to make all of these decisions on a very quick basis in real time.
As we go through this transition and we keep looking for ways to collaborate, to provide visibility, to create more predictable type of energy demand, we're recognizing that something which you said earlier, which is for a lot of these things to happen, we have to have an investment. So I was reading the other day that the International Energy Agency, they've indicated that to get to global net zero, it would require $640 billion in investments each year in energy efficiency financial capital. How can we increase capital being spent on smart buildings and retrofitting and the modernization efforts that are required?
Well, that's a good question. I would say, let's ask for some additional funding. We are seeing a massive, increase in capital expenditures for efficiency, climate, impact, et cetera. Whether it be in the U.S. for the bipartisan infrastructure bill, the Inflation Reduction Act, and even in Europe, the Repower Europe. So we are seeing significant funding, which is great. It's a first step. We need more funding. We certainly need governments to fund. We need private companies to step up and fund. We need multiple multinational funding organizations. So we need all of these funds really to do a lot of the work. But we also need funds to invest in new technology development and coming to scale. So we need funding. But, Chris, as we've talked about, certainly funding is not the only answer. We need policy, good policy. We need funding, and we need an implementation or a transition plan that are all aligned. So, as we look at this from AEE and our members and certified professionals, and really the AEE family around the world. Our vision is to lead the global energy community to meet the challenges of a clean and sustainable future.
That's great. Bill, thank you so much for your insights today, your perspective. Thank you for all that you're doing, not only here locally, but globally. Clearly, the opportunity shift of our energy consumption, that shift is ahead of us. There's a lot that we can do, and a smooth transition, as you referred to it, I think is a relative term. And I think today we heard firsthand the importance of incorporating organizations like yours to be part of the overall solution, whether it's through policy change, to incent financial public-private investment, that focus on data and AI, just the analytics of it, providing more information so we can do things smarter and maybe more real time, and through innovation and technology breakthroughs that you were referring to. I think these are all these things that we're going to need to find better ways to minimize our power demands. But one thing is clear, it will take a global effort from all of us, not just from some of us. So Bill, thank you for being part of the solution. Thank you for your time today. And everybody else, thank you for watching. Please watch the rest of the Top Trends in Energy video series, which features other industry experts discussing the latest trends they're seeing at the intersection of technology and energy.